All right, so we got an example problem here from the ULB textbook where we are going to try to solve for the power dissipated by RL. Okay, so that's what we're trying to find. Sorry, I didn't give myself much room there. Find PRL. Okay, and so basically what we need to find is the current flowing through RL. And so what we can do is we have an auto transformer here, so we can actually use mesh analysis to determine these currents, these loop equations, right? I can draw my plus minuses here, here, here. And of course I know that this voltage here is my primary, or I'll call it V1. This voltage here is my secondary. And we know those relationships. That's pretty straightforward. We know that V2 is going to be equal to V1 times 6. And we know that I2 is going to be equal to I1 times 1/6. Okay, pretty straightforward for those two. But then we can write two loop equations here. We have four unknowns, right? We don't know V1, V2, I1, or I2, but we have these two equations, and now we can write our two loop equations, and then we'll have four equations and four unknowns, and we can solve the system. Even though that sounds like a nightmare, it's not going to be that bad. 20 angle 0, right? I'm starting here and going this way to solve my KVL. Then I have a drop of I1 times 4 ohms. Then I go up by V1, and then I drop, right? But I have two currents there. It's going to be I1 minus I2, and the impedance there is minus J16, and that whole thing is equal to 0. So that's my first loop. My second loop here, I'll start here and just go this way. So I drop by V2 right off the bat. Then I drop by I2 times 144 ohms. And then I get to my capacitor and I drop. I have two currents again, I2 minus I1 this time. And that's also going to be minus J16. And I set that equal to 0. All right, so I've got four equations and four unknowns. What I'm really after is I2. And so what we can do here is, since we have these two equations, we can basically represent all our V1s in terms of V2 and all our I1s in terms of I2. And then we can just solve this system of equations for V2 and I2. And once we get I2, that's all we need to determine the power through RL. Okay, so let's go ahead and do that. Let's rewrite equation 1, but with all of our V1s in terms of V2. So it's going to be 20 angle 0 minus, and our I2s, or our I1s are going to get converted to I2s as well. So I1 is equal to, or I2 is equal to, I1 is equal to 6 times I2. That's what we wanted. So right here, my I1 is going to get replaced with a 6 times I2 times 4 ohms. My V1 is going to get replaced with a V2 divided by 6. Okay. Then I get minus I1, which is 6 times I2 minus I2 times minus J16 ohms equals 0. So my first equation is now just in terms of I2 and V2. And then let's write our second equation again. Minus V2 minus I2 times 144 ohms. And then I just need to replace I2 minus 6I2 minus J16 equals 0. All right, so I've got my two equations now represented here in terms of I2 and V2. I'll go ahead and solve the system and just save us some time so I don't have to chop through this algebra on camera. I'm going to end the video now that this is set up, and once I've solved the system, I'll come back and kind of talk about the end of this problem, finding the power dissipated by the resistor. Okay, so I'm going to end this video right here.